perfectly smooth. Then here the liquid will exert a force P1A. So till here there is a liquid. You can write like this P1A something, and okay, till here only will write it. Okay, let the H be the, it's like a cylinder, we can take it. So now what is the forces that are acting here? So normal contact N1 will act. So what are the equations you can write? N1 minus mg minus P1 equals 0. What is P1? P1 is equal to how much? So we can write rho, density of liquid rho, rho L, rho L G Y naught. Okay, this is the expression for normal contact. Fine. So what is the buoyant force? No buoyant force. Huh? So no buoyant force. No upward thrust, I'll call it. Huh? Any reason? Because what do you mean by buoyant force? Net force exerted by the liquid on the solid directed vertically up. Now the same solid, now little bit the bottom, it is slightly rough. Not very much, slightly. Then so practically which is possible? This is theoretical. Huh? Practically this what happens. The second case is what it happens here. So what is the weight? Mg. Then here the forces that are acting are P1A, as usual the liquid is still here. This is Y naught. No. So what is the normal contact here? No. Let it be N2. Along with this, the liquid will also exert a force here. The liquid will exert a force. So what is P2A? P2A what we should call? Force exerted by liquid present below the solid. But sir, like it is a very small, no sir, it is a very small, microscopic, it will be like a very, very small amount of liquid. That is enough. Okay, let's calculate here. So it's in equilibrium. What I notice in equilibrium. So then definitely here, what all we can write? N2 plus P2A minus P1A minus mg equals 0. P2A what you can write? P1 plus density of liquid rho L GH. P1A, I think P1A anyway it will get cancelled. Now you see this N2. P1A get cancelled. So N2 plus rho L G EH minus mg equals 0. Now what is rho L AHG? Buoyant force. Okay, tell me like a small microscopic, it's a like a small amount of liquid, like a rough surface rough. Now practically what is possible? There's a theoretical, perfectly smooth, it's a ideal, not possible. You take any object, it will be definitely rough. So there'll be a buoyant force, that's all. So this is ideal case, perfectly smooth, it's ideal. This is a practical. Getting the idea? No? So like this, what happened? We can have a situation. So I'll later on I'll shade it. I'll show some liquid below here. That everything is liquid is present. So it's like how much of liquid should be there below the at the bottom of the object, I think small amount of liquid is present. That is enough. It will, with that weapon, a upward thrust will be generated. For that, it need not like something like a more liquid is present. The amount of liquid should be present here should be more so that bind force will act. It doesn't matters. Okay, we thought that what we thought. Okay, there's a very small amount of liquid. So what is the pressure here? Let it be even few drops. That is enough. The pressure at that point will be greater than P1 and that will come upward thrust. Got the idea? So these are the essentials which we must know. Huh? So some small ideas, that one. Huh? With the help of this, tomorrow what happen? We'll go for further exploration of this buoyant force, like how it will set up a torque, how it will accelerate, all different numericals. We'll take it here. So what you have concluded? No, buoyant force is what density of liquid volume immersed into G, or so it's like a weight of the displaced liquid. So now you can ask questions, sir, why you are not talking weight of displaced liquid? The idea of weight of displaced liquid will come when you are able to notice it. Suppose you put some wooden block in a lake. Can you notice the change in level of liquid in that lake? Not possible, no? So there will take help of buoyancy, where you are able to find out the displaced